Please turn on your camera. What we have last week, chapter 4 is about integral, and this chapter is application. In my opinion, this chapter is very important, and in many cases, it is more difficult than the simple computation of integral, because you have to recognize the case you are given and think what method can be applied. Okay, so first we talk about volume. Last week we studied the second dimensional, which is the area of the region bounded by some curve and some lines. And we developed this method, the idea of this method for finding area, to the case of three-dimensional, which is the volume. Okay? That very important. We have the same idea. And because of that, you will see some students already look at my lecture note, and you could noted that besides the first part of this chapter, the other part I wrote in italic. It means you have first, it is the same as non-italic. We talk about from the beginning of today's lecture. And the second, you do by yourself, study by yourself, such an idea. Okay? So the idea is the same as for area. We try to use the definite integral to make the volume as many pieces and precise what you have the solid mean. Before that, we need to know or recall what the volume is. What is the volume? On how to compute it? Yeah, we know that the same for the area. If we have the regular in the case of R2, we say the region, right? But in the case of three-dimensional, we call this solid. Solid is three-dimensional, a region is two-dimensional. And if we have such a regular solid, it is easy. You know from the high school. In the case of cylinder, you multiply the area of the base and the height. In the case of circular cylinder, the area in this case is PR square. That's why we have PR square and multiply by the height, right? And for rectangular box, the same. When you have H like this, the area in this case is product of two sides, length, long, and wide. With that, very easy, we understand, right? But what happened in the case non-cylindrical case? Not such a form, not regular at all. Then, in this case, please remember, we use the so-called cross-section. Cross-section, what is that? Cross-section is the part of the solid lying on some plane. What is in Vietnamese? Do you know?
Mặt cắt ạ.
Mặt cắt ạ.
Mặt cắt, chính xác, mặt cắt. Và nếu tôi không nhầm thì khi xưa tôi học có dùng từ Hán Việt tức là thiết diện.
Thiết diện.
Hiện nay có dùng từ đấy không?
Có.
Ok. Diện nghĩa là mặt, thiết nghĩa là cắt, chẳng qua đấy là cái từ Hán Việt thôi, tức là mặt cắt. Yeah. So we use cross section to work on the case of volume. What to do? Okay. So we try to consider the intersection of the given solid by some plane px. But px here with the subscription x mean the plane perpendicular or orthogonal to the x-axis and passing through a point with the coordinate x coordinate is x in between A and B. So you can see here, we consider from A to B, and x is in between. At that x, we take px as the plane perpendicular to the x-axis. So which means that px is perpendicular to ox. That perpendicular, right? Then we have the area AX of the cross section, diện tích của cái thiết diện giữa cái px và cái mặt và cái đường và cái hình trong không gian. That we do like that. And then this again we call this region between px and s by cross section, and we denoted it area by ax. A again stand for the area. Okay, so and in general we should have this formula: integral from a to b ax dx. And remember, ax is area of the cross section must be non-negative for all x from A to B. At the end point, it might be 0. It can also happen at some point inside, right? If we have the cross section is only one point. But the question is how to get this formula. So here there are two main ways for calculating area by that. First, we use the so-called cross section, okay, and the other we use the so-called cylindrical shell. Từ shell này có nhiều nghĩa. Ví dụ như là thời chiến tranh người ta dùng cái hầm trú ẩn này thì người ta dùng từ shell. Thì cái cylindrical này nó rất giống cái hình cái hầm trú ẩn hồi xưa mà các em thì bây giờ các em không biết, có thể là bố mẹ các em và ông bà các em thì sẽ biết nhiều về cái này. But okay, we will see what it is. Okay, so first, how to use the method of cross section. This one of the two main methods. And by that one, as you remember some minutes ago, I talked about you have to understand what method you can do and what method you want to use. This is important. So more important than this simply computation of the integral. That's why chapter 5 is application in some sense more difficult than the simple computation in chapter 4. Okay, so here you see, even for this method, we can have three types of the solid for which cross-sectional method apply. First, general solid, in general. The second, solid of revolution or rotating. Cái này trong tiếng Việt cả hai. Một cái thì ta gọi là disk method, tức là cái phương pháp đĩa vì nó giống cái đĩa. Và thứ hai là phương pháp máy giặt. Đấy, tiếng Anh thì nó có hai cái từ this method and washer method. But the solid revolution or rotating là quay á, thì nếu tôi nhớ không nhầm trong tiếng Việt người ta dịch là khối, cái khối, chứ còn mặt chỉ là bề mặt thôi, tròn xoay. Tôi không biết là hiện nay các em có học cái câu này không, nhưng mà một cái hình nào đấy nó quay quanh trục OX và OY thì người ta gọi là tạo ra cái khối tròn xoay, bề mặt thì nó gọi là mặt tròn xoay. Okay, we have three general methods for that. First, very general, and the other two for rotating or revolution solid about some axis. Okay, so first one, this method can be applied, cross-sectional method, to any solid as long as, what does it mean? If, whenever, provide, so một loạt từ, tức là một khi mà, hoặc là trong trường hợp chúng ta can be counted, found the cross-sectional area. Vậy một khi mà chúng ta tìm được diện tích AX thì chúng ta sẽ có được kết quả. That this method means. Okay, so what to do? The same idea as we did for the area problem. And I want to ask you to see at the appendix at the end of the chapter. Okay, so remember, how about the area? The area from A to B, we divide by the so-called curved trapeze, right? And for each small one, we look at approximation by rectangle. So when you have that one, this one, for example, you have that, then we can take either this part or bigger part or some in the middle. It's up to you. We talk about three cases of the xi star. And then we let the number of the division tend to the infinity, and you have the whole area. That's the same for the volume we talk about, which mean when you divide it, do I have the picture here? I don't have. Yeah. So here at least we come back to that because I don't put it here, my appendix, but you can look at that. Here you see, when you look at this and you divide it by many sub-intervals, then more or less you have something like that. And the air we consider as the cylinder, very similar. And then it is the volume of that part is AX, a base multiplied by some H. H here is delta X, this part. Then we let the sum of this AX star, which means that the intermediate, and then we let this sum by n tend to infinity. If the limit exists, then we call this the volume, exactly as for the area. See, you have that, the volume of approximating, and then we let the interval AB divided by n part equal b minus a over n, and let n tend to infinity. If this limit exists, then we call the value is the volume of the solid and we denote it by integrand from a to b ax dx. So why we get that? See the appendix. Exactly the same idea, only we move to the R3, right? So such a thing. And of course, if AX is continuous, see, then the definite integrand exists and we get everything. Such an idea we follow and we don't talk in detail because the same idea from the area, and you can look at this in the appendix. So what you have to pay attention. Remember, AX in this volume formula is a function of X. And this is the area of the cross section of the solid and the perpendicular to the x-axis plane. That you should do, okay? Next, variable here means that you take the x-coordinate. X-coordinate that between A and B. And of course, depending on the side of A and B, it can be negative. It can be negative. If you take from -1 to 2, then of course, this part, you have negative x. So it doesn't matter. But the main thing is AX. Here I write positive because in the case 0, you get nothing. So this remark you should pay attention on. Okay. Now look at the example. Show that the volume of a sphere of radius r, or we can use sometimes we say volume of a ball. Tức là cái hình cả cái khối cầu rồi, chứ không chỉ nói đến hình cầu, cái mặt cầu nữa. Đây ta hiểu cái từ volume of a sphere means that là cả cái phần inside is 4/3 pi r cubic. You know this formula quite well, but how to get it? Now look at that. First, we should pay attention on that one, which means you need to build up a coordinate system. You need to build up a coordinate system O, X, Y, Z like that. Where is original? Where is X? Where is Y? Where is Z? And then from that, you try to take PX, the plane perpendicular to x-axis at a point with x coordinate, and find the cross section with the solid. And after that, you get the area of this cross section and substitute to this formula, compute the integrand, you get the volume you want, right? And here you see, I build up a system, coordinate system like that. Center of the sphere or of the ball, I take the origin of coordinate. And then I put X and Y and Z. Here no need Z because we see the actually Z on that side or the other side, it doesn't matter. Mainly we need the X and Y, and actually we need X. Here, cross section at X. What is that? That cross section. This is cross section, and we want to find the area of this when X run from negative R to R, right? So the cross section is a disk, right? This is a disk. So when you cut the ball by the plane, you have a disc, and that disc, the radius is y, because the height with respect to this axis. So you have area is pi y square. Y is y of x. Y is a function of x. And then you have to represent y in terms of x, and you take the volume is integrand from negative r to r, ax dx. And you get the answer. Should be 4/3 pi r cubic. Okay, now we do. What is that? Cross section, radius y. When you have here, of course, you have x squared plus y squared is r squared, right? So that's the reason y is square root of r squared, correct? Is square root of r squared. Yeah, minus x squared. Then y squared is r squared plus minus x squared, and you can have this as a function of x. Now we apply the formula integrand from negative r to r, ax dx, and of course it is the continuous function for x. And the interval negative r to r. So computed it. Very simple. You use fundamental theorem of calculus or Newton-Leibniz theorem using the antiderivative. You get the answer. So very easy to do using the integrand. But the most important is to establish what the area of the cross section is. This is important. Okay, so this example illustrates what you can do. Now, this is general, but in general, not easy to find the cross section. And of course, surely it leads to another difficulty. How to compute AX, the area of the cross section. If we cannot do it, then we cannot use the formula. So that's the reason usually for the practice, you more or less know how to find the area of the cross section. There are two cases in this solid of revolution and using this method or using the washer method. Particular case, we have so-called the second kind of the solid. What is that? What is that? The solid generated by rotating, or we say sometimes use the word revolving. That's why we have the so-called solid of revolution. Come from here. This is a plane, a region on the plane. We rotated it about the axis. Then we have the solid of revolution or solid of rotation. Cái khối tròn xoay, as I mentioned from the beginning. Okay, so in this case, very easy to find what the cross section is and how about its area. Okay, so here, for example, we look at this example, we understand how to work with this method. Find the volume of the solid obtained by rotating about an axis. What region? The region under this curve from 0 to 4. Which mean when you have x, y like this, suppose you have some curve, right? I write, for example, some curve here from 0 to the 4 is 4, 0. Then you rotate about x-axis. In this case, you have this picture, that one. See, like the flower vase, giống như là cái bình hoa đấy. Đấy, khi mà các em quay xung quanh cái trục OX này thì cái hình các em nhận được chính là cái bình hoa, giống như cái bình hoa. That the so-called this method. Why this method? Because in this case, the cross section is a disk. Is a disk. Đấy, thiết diện là một cái hình tròn, cho nên người ta gọi là this method. Okay, so here, look at that. What is that? You start with the curve. Okay. You start with the curve square root of x. And you can see from 0 to 4. Here, square root of x. From 0 to 4. And passing 0. In this case, when you're rotating, you see this side of rotating, you get that solid rotating about x-axis. Of course, it is not the same as the vase I wrote here, because here it doesn't pass 0. So you have the base, right? So here you don't have base. It doesn't matter. You have such a thing. And take the px. You have a cross section is a disk. A disk. And that one, the radius. What is that? This is the radius. This part, square root of x. This square root of x. So you have the area is pi r square x, which is pi square root of x square is pi x, right? That you have ax, done. Using the formula from 0 to 4, you get the answer. That pi x, because the disk or circle the same, and the area from 0 to 4 is 8 pi. This is integral. You get the volume. So that's the reason we call this method is this method, because you can compute the area of the cross section as the area of a disk or circle. Okay. So similarly, you can think about the solid obtained by rotating about x-axis, about y-axis. So suppose you have that area, and when you rotate about y-axis, you have such a solid. See, giống như cái đĩa bay. This is y-axis, and in this case, you should compute first this area from C to D. So integral ay dy from C to D. Here ay, because you take now the integration with respect to y, not with respect to x anymore, because you have the rotating about or around y-axis. Okay, so such a thing, you should change everything to y, from x to y. Now, in summary, you need this slide and should remember this slide. If you rotate the region about x-axis, then the volume here, and of course, you can change ax by pi rx square. If you rotate about y-axis, then volume here, dy from C to D, and ay is pi ry square. That, pay attention, learn by heart this one. Learn by heart nghĩa là gì? Học thuộc lòng đúng không? That you should remember. Remember and learn by heart these two cases for this rotation. Okay? Volume by this rotation about x-axis and about y-axis. And now we move to the first method. First method is general, but very difficult if you cannot find AA. But the second method is this method, and the third method is Washer method, also easy. Both are the same in some sense. How? What is the third kind of the solid? You have a solid obtained by rotating a region around x-axis or y-axis, but the main thing is this region is bounded by two or more curves. You see, for the second method, this method, you have only one curve and rotating, see? But what happened? In the case you have two or more curves like that, see? You have this curve, Rx big, R small, and the area here, that part, you rotate this region. Then you can imagine by bigger upper curve, you have big vase, cái lọ hoa to. But by smaller one, lower R small x, you have inside another vase. And the reason you have is that part, which means bigger volume subtract smaller volume, right? Then you have this region rotate. And how to have this? Yeah, when you take the cross section, you can see you have only that part in between, which means if you look from the above, you can see that you need to compute this area and these two, that one and small one, are two concentric. Concentric là gì? Là đồng tâm. Hai đường tròn đồng tâm lồng nhau như thế này, và các em phải tính cái diện tích ở cái phần giữa này. Thì có phải nhìn từ trên xuống, it look like washer, giống như máy giặt của các em đấy. Cái này là cái thùng này, thông thường là cái thùng này nó to lên thế này. Các em để quần áo vào trong này, thế còn cái phần bên cạnh này để nó quay cái này nó không bị chạm vào bên cạnh đó. That's why we call washer method, because it look like the washer when we look from above, right? It called washer. Two concentric circle, hai cái đường tròn đồng tâm với the same center, a center here on the x-axis. So, for example, you rotate the region enclosed by y equal to x and y equal to x squared. First, very important, you can sketch the region. And then you try to see how about the three-dimension solid after rotating. Here, you can see, this is y equal to x, the upper, the lower here. And when we rotate it, you have such a thing here after rotating, right? that only small part you have rotating. Then cross section is what's cross section here? So first, rotating around x-axis, and we have to integrate with respect to x. The shape of the cross section is like washer. Washer here you see the inner radius and the outer radius, x and x square, right? Here, x, from here you have this is x, y equal to x, and that one, y equal to x square. That, okay? Inner is x square here, outer, that part, and this part is x. So you take area by x square, and by x square is small. This is rx, this is small r. You take the difference of the area of two, this you get the answer. Okay, so here, that's why the area here is bigger this, subtract smaller this, and you have this formula, ax is pi x squared minus x4, and then compute from 0 to 1. You get the answer 2 pi over 15, right? So this is the washer method because you have concentric. So here the answer by washer rotation, which means that you have two discs concentric, bigger disc, the area, smaller disc, the area, subtract, you get the area of the cross section and take the integral. Okay, so that's the thing. This is the thing. Cross-section method. And now we move to the second case. We compute volume by using cylindrical shell. What it is? What it is? First, you should understand what the method is, and then you use the formula to calculate it. This is more difficult than the cross section. However, after having this method in your hand, you will be having two main methods, cross section and cylindrical shell. And for many problems, you can use both methods to compute the volume. And mainly they are the same level of difficulty. However, there are cases, if you use cross-section or you use cylindrical shell method, your computation is simpler than the other method. In this case, you should think whether you can use this or that method, which is simpler to compute. It doesn't mean that cross-section is always simpler. No, formula is simpler. But how to get this formula? You should be careful with that. Okay? So now we look at this. Suppose you have cylindrical shell. Giống như là gì? Chẳng qua nó giống như là một cái hình mà nó có cái độ dày đây này, cái độ dày là giữa hai cái hình cylindrical, tức là hình trụ, thì có một hình trụ to và một hình trụ bé nằm trong. Như thế này thì giống này, giống như là cái đường ống dẫn dầu. thì các em thấy là đường ống dẫn dầu nó là hình trụ, nó nằm ngang. Đấy. Và rõ ràng rằng nó có cái độ dày của cái vỏ. Thì đây chính là độ dày của cái vỏ này này. Đấy, đấy là chính là độ dày của cái vỏ. Và đấy nó giống như là cái cylindrical cell là như thế đấy. Là cái cell mà có hình trụ. Đấy, cái cell người ta hiểu là như vậy. Giống như còn ở những người lớn người ta hiểu đấy là cái hầm trú ẩn. Hồi xưa là toàn hầm trú ẩn như thế này ở trên đường phố của Hà Nội ạ. So inner radius is R1, tức là cái đường thẳng bên trong này này, các em nhìn trên xuống cũng giống như hơi giống cái cylindrical cái cell ấy, cái washer cell ấy, thì là cái bên trong này là R1. The outer radius is R2. And you have the height. The height is h. This is the height, right? Of độ cao của cái cell này. So in this case, volume is what? You take the bigger volume, subtract the smaller volume, then you get this one, right? This cylindrical cell. A bigger volume is, you see, area pi R2 square, right? This is R2, and the area is A is pi R2 square, and then multiply by h. This AX, you have h multiplication integral. That's why volume. The other also volume. And the answer, we manipulate this result to have R2 square minus R1 square by h. We defactor in R2 square plus R1 square, R2 square minus R1 square. And that you have 2 pi. You multiply by 2 and divide it by 2, and then h multiplied by R2 minus R1. So this one is what? The difference between radius. So we write delta R, means the thickness. Đấy, cái độ dày của cái đường ống ấy, nó có thể mỏng có thể dày. Thì thickness of the cell là difference between two radius. The average radius, trung bình cộng của hai cái radius. So in this case, we can write V is 2 pi R multiplied by H multiplied by delta R. Where you see what is that? Đây chính là chu vi. Nhớ nhé, chu vi trong tiếng Anh người ta dùng là circumference. Circumference of a circle. Chứ người ta không dùng period of the perimeter, no. Not perimeter. Perimeter là dùng cho đa giác. Thế còn đây là circumference of a circle. H is height and delta R is thickness. This is the formula for the volume using cylindrical shell. So how to find the volume? Again, you can see the idea is we divide it into this part, this area, and rotating. And of course, by that, we can use the cross-section. See, you can use the cross-section. We study in the method 1 to find it. Right? That's very beautiful picture. And that's why I always ask and advise students to sketch the region first, and then to sketch the solid obtained by rotating the region to see what happened and how to compute easily than without picture, right? So then you see the same idea to find. You can look at the appendix. I don't mention here. But the formula you have to memorize is average circumference, height, and thickness. That's all. That's what you have to remember here. You don't have to remember how to do. Just read the appendix, the same idea for the area up to now. Everything for the volume, the idea is the same as we did for the area. Okay? So, for example, find the volume of the solid obtained by rotating about x-axis. Very important to read this. About x-axis or y-axis. Here, y-axis. Region bounded by this curve and y equal to 0. So you should know what the graph of this function, and then you sketch the region. Okay, so this here, y equal to 2x squared minus x cubic. You see, if it is 0, you have x squared 2 minus x, which means that it intersected with the x-axis by x is 0 and x is 2. You see x is 0 here, x is 2 here. And that's the curve. This curve 2x minus x squared. Y equal to 0, which means that x. So you have this region. And this region now you rotate about x-axis, then you get about y-axis, then you get these things. Look like cái gạch tàn thuốc lá, đúng không? Something like that. So you need to compute the area of that gạch tàn. Okay. So then 2 pi x height, thickness, integrand from 0 to 2, you get 16 pi over 5, which is your answer. So very interesting, and pay attention, read carefully the example and do it again, right? Cylindrical shell at coordinate x, radius x, height fx. Fx is 2x squared minus x cubic, because you have such a thing here. This is the height, right? It is the h. At each x, this h is the value of a function 2x squared minus x cubic at x, which means that you get this here. That height. Then thickness is different, right? Between delta R1 and R2. Yes, you have this. Okay. So, and here we use the so-called cylindrical shell method. And the question is, can we use cross-section method? The answer is, do it by yourself. Give the answer. Which one you can use? Maybe only cylindrical shell or only cross-section, you can compute easier, or both the same. And very important to determine what method you have or you want to use. Then apply the corresponding formula. Okay? So it depends on how easy, you see. It depends. If cross-sectional or cylindrical shell, which one is easier to find the area, then you use this to work on. Okay? So often, see, both methods are the same. So example above, you can use even the cross-section, right? So such a thing, very interesting to compute the volume, especially volume of rotating So region rotating about either of two axes, and you have different formula to work on, and which, unless it is require you to do by the specific method, you can use whatever you want. Okay, so general guide. If an axis, try to build up the coordinate and then use the perpendicular plane to get the cross-sectional, and then for cylindrical shape, you have to see the cylinder parallel to x-axis and integrate to with respect to y, for example. So it depends on what axis you have to do. Here, the same, only you change the role of x and y. That's the general guide for computing rotating region, the volume of rotating region. Okay, so short break, about 10 minutes, and then we move to the arc length and the surface area, tức là độ dài của một cái đường cong và cái diện tích bề mặt, hay là diện tích mặt. Sau này ta sẽ có là diện tích cái mặt tròn xoay. Okay, so the short break. We continue our lecture, please. So, and again, now you can turn on your camera. So, before we talk about the second part of the lecture, I want to remind you that we intentionally to have your midterm on Saturday, 18th of December. However, on this day, and maybe also on 19th of December, linear algebra will be tested. That's why we move our calculus to some day in January, not in December. And then we will restrict the content for some chapter. Maybe I keep the same chapter 1 and chapter 3 for this midterm in January. Okay, so such the things. And now we move to the length, arc length, and surface. So for those who are late or I don't see they turn on or turn off their camera, don't ask me again what I already explained, because this is during the lecture, not out of lecture hour. Then I won't answer again. Okay, that you have to follow what I said and what I wrote. From the volume, now we move to the arc length and surface. How to find arc length, which means if you have some curve like that, y equal to fx, and I want to find this path from alpha to beta, how about the length of that? If you have a smooth curve here means that the derivative f prime of x exists. I already explained the word smooth, right? Okay, so that differentiable function as smooth. I just talked about how to find the arc length. Arc length, it means that the part of the length of the curve from one end to another end. Okay, so the idea again the same. You see, everywhere in this chapter, the idea is the same as for finding the area and the volume. Divide the interval into an equal subinterval, approximate each interval, the length, and then perform the sum. And finally, the fourth step is taking the limit. Everything we follow in the application of integral, these 4 steps. Okay? So, and that's why all what I ask you is where I write in italic, you read by yourself. We explain very fast or skip to go in detail. First, how about straight line segment? Simple, right? When you have straight line from this point to that point, x1, y1, x2, y2, then the distance means the length of this curve. Curve is simple. That straight line. You have actually, this is the distance between P and Q, right? Which is square root of x1 here. That one minus x2 square plus y1 minus y2 square. This is the straight line. You know quite well. By Pythagorean theorem for this right triangle. That one you have. Very easy. The simplest kind of smooth curve, which is a straight line. Okay? So here formula. No problem with that. But this can be found in another way, using the angle of elevation, which mean, what does it mean? You can think about this P1 and P2 as I write here. You can think about using this theta, which is that angle. That you can also use to have the length or distance from P1 to P2. Look at the appendix. So we have appendix to talk about this. Okay. So here, as I repeat here, right, the arc length can be found. See, the same what I repeat, and we try to write this distance in another way. Here on italic, you see that theta and delta x, delta y, and from that you have the tangent. Tangent of this is that delta y over delta x, right? Em học rồi. Tang là đối trên kề, đúng không? Tỷ lệ giữa cạnh đối và cạnh kề. And this one, we can have delta y, the distance from here, from that point to that point, is delta x and tangent. So that using the formula, that distance is square root of delta x squared plus delta y squared. You know delta y is delta x and tangent theta. Substitute there. You get that the distance from P1 to P2 is delta x multiplied by square root of 1 plus tangent square of theta. And that one, you know, is a slope. Hệ số góc của đường thẳng passing P1 and P2. So that you have square of the slope. So from this idea, we try to apply to the curve, not necessarily straight line, any curve which is smooth, right? So the same thing as we have done. See, I write cell study. First, divide into different parts. You see, it looks like the area when we talk about. And then we approximate this arc, right, by straight line, the same as that one. Okay, so sampling point, you know, tangent line, you know, this is linearization. Linearization we study already, right? And then after that we find this formula here, explanation, please read by yourself, and then you get the fourth step, sum up. The third step is sum up, and then the fourth step, you take the limit. Then it done. The limit give you this result. You see? So on these four steps, you follow the same as we did for the area. Finally, you get very beautiful step. Very beautiful step. Yeah. Should again, like the other method for volume, learn or remember by heart this formula in application chapter 5. Suppose you have a curve y equal to fx defined on the interval AB, and more than that, there exists derivative f prime of x, which is continuous. So you remember f on AB with f prime, and f prime must be continuous on this interval. So very important. Continuous here give you the existence of definite integral. Ensure that existence. And in this case, the formula is given by such the form. The L from point AFA to BFE on the curve y equal to fx is computed at the integrand from A to B, 1 plus f prime x squared dx, or you can write y prime squared. So this is formula you need. And because y prime is continuous, then y prime square is continuous, plus 1 continuous, square root continuous, and you have the integrand. That integrand see, that integrand is continuous. So then the definite integrand exists. We already talked about that in chapter 4, right? That's why this condition is very important for applying this formula. You have to be sure that f prime is continuous, not f. F surely continuous because there exists derivative. Differentiable then imply continuity. But f prime exists only give you the fact that f is differentiable and continuous. But itself, f prime is continuous or not, we don't know. We don't know. That's why we need this assumption to apply the formula for arc length formula. Okay, so pay attention on that. See, I wrote here, explain very clearly. We require function f to be not only differentiable, but f prime must be continuous. In this case, we say f is continuously differentiable function. Yeah. This ensures that the limit of Riemann sum exists, which means that the integral, definite integral exists. So pay attention, because I mentioned several times today about this assumption. Okay. For example, find the arc length of the semi-cubical. Sometimes people say, depending on the what English you use, semi, or you can semi, is this the same? Parabola y square equal to x cubic between the point 11 and 48. So now you see this curve like that, this and that part, because when y non-negative, you have y is x3/2. But for y negative, you have y is negative of x to power 3/2. That y, and here positive. And you are asked 0.1, x equal to 1, then y equal to 1 from here. X equal to 2, x equal to 2, so here should be 2, right? Correct? Not y I write 8. X a point, x equal to 2, yes, 4, yes, because we need square, correct. So x equal to 2, so x equal to 1, then y square is 1, then y is 1, because we talk about upper part. Here, if x equal to 2, then y square equal to 4, then y square is 64, and then y is 8. Yes, we have 4 and 8. So that part. And you are asked to find this length. When we talk about y bigger than or equal to 0, then of course we have this y is x to power 3/2, and this is smooth, or I mean the differentiable function. Then you apply y prime is 3 square root of x/2, and the formula arc length L is integral from 1 to 4 square root of 1 plus y prime square dx. Work on that. Very simple. You get, oh, you see, the result not so beautiful. And I have to show that if I give you this question for your midterm or your final exam, of course, final exam, not midterm, I promise to test you midterm for the first 3 chapters. That I mentioned from the beginning of the second hour. How about 15 minutes ago? Okay. If I give you this question for the final exam, I'm sure that many students wonder whether the computation is correct or not. Because you see, look at this, the formula and the answer not so beautiful. But it happened that you should have such as the answer, not beautiful answer in your mind was square root of 10, square root of 13, but it can work. So pay attention. Not every question I give you, the answer beautiful. Or in Vietnamese we say, thưa thầy, cái công thức này, cái bài toán này hình như là ra nó số lẻ chứ nó không chẵn. Lẻ chẵn hiểu là beautiful number or non-beautiful. But it can happen like this. So be sure that you compute rightly. That's the big things you have to do. Okay? Now, if we talk about the arc length from one point to the other point, sometimes you need also a function that measures the arc length, right? That's a function. So, suppose, for example, you have a smooth curve. The equation y equal to fx from A to B. Smooth here, I remind again, meaning is there exists f prime of x. So there exists the derivative, or smooth mean a function is differentiable on the interval AB. So, and now, suppose you have this curve y equal to fx, and you start from a point A, FA, that point. And for any x in between A and B, so if that, I erase this part, okay, and I use only the part from here to here, okay, that one. And at that point, every point x in between A and B, I have this length depending on x, and I denote it by S of x, which means the length along the curve from a point AFA to a point X, and then here FX, right? FX. So then you have SX for X from A to B, correct? S at A is 0. S at B is the whole length of the curve from A to B, right? So we can have this as a function of x, okay? That's the thing we talk about. And the question, how to compute Sx? Here, add x from here to here, which means that this is the end point of the curve you want, the arc length, and you apply this, you get the answer. 1 plus formula, this is y prime or f prime, square root, and integrand from A to x. So you see that you apply the arc length formula to this situation, you have a length, the length of the curve from here to here, which is Sx, right? So you have such a formula. For example, find the arc length function. Pay attention. Find the arc length. Then from what point to what point? But the arc length function, you are given only the starting point. As the end point is some x f(x), okay? So that's why we have only one starting point, 1, 1. We don't have the end point. End point is any x in between. So this is AFA. X is in between A and B. depending on what B you are given. But by that question, of course, you understand that the domain of definition is 0 infinity, because you have a function logarithmic of I. But it doesn't matter. You can start from 1 and 1, which in this interval is okay. X equal to 1, right? Actually, it here, domain of definition plus infinity. And if you take 1 here, X is 1 inside this area, this interval is okay. But now you apply the formula, here formula, from A to X, from 1 to X, 1 plus f prime square root. From 1 to X, 1 plus f prime n square, because f prime is 2x minus 1 over 8x square, and you get this integral. Do it by yourself. Very easy to use, for example, square root expression. You get the answer here. You can reduce to such a case. T from 1 to 8, and of course, if you take x is positive, modulus doesn't matter, right? So here, because positive, you can remove to have this one, and the answer is S of x means that from 1, 1 to some x f(x). For this case, the length here, that the length, x squared plus logarithmic of x over 8 minus 1. So up to now, you have the arc length of the curve from one point to another point. You have the arc length function from one point to some running variable x point, right? As a function of x. So then you see, this is the curve. P1 or P0, yeah, I write P0 is 1, 1, that point. And this length, depending where x is, x here, x here, x here, so depending on that, you have the answer for the arc length function. And here the length, when you represent in this plane, here plane for y equal to fx, but here plane y equal to sx, then you can have s like that, x squared 1 over 8 logarithmic of x over 8, and then minus 1, and that here is the curve of the arc length function. By this example, you may be aware that it can be asked to sketch or plot, right? This is the same as sketch. Sketch, đất là chúng ta phác họa. The graph of the arc length function. You first have to compute what the arc length is. You compute this answer first, and then you sketch that one. See, you have this graph for SA. Sometimes you are asked to do so. So pay attention. Okay. So, what do you think that why S1 is 0? Because you start from 0, right? You start from 1, 1 to x. Then this length, the first point is 1, 1, and S1 is 0, right? So another, why is as x less than 0 for x is in between 0, 1. X is in between 0, 1. Then the length is coming back in the other direction. That's why it should be less than 0, because we starting from here 0 and then bigger than 0. Then the other direction is less than. After having the arc length, we move to the so-called surface area, tức là cái diện tích bề mặt. We already discussed how to find the volume of a solid rotating solid. But now we want to look at the same solid of rotating or revolution. We want to find the surface area. Một cái khối các em quay, một cái hình trong phẳng các em quay quanh trục, các em sẽ được một cái khối tròn xoay. Thì khối tròn xoay đấy các em tính được thể tích. Chúng ta học rồi rất nhiều phương pháp, đúng không? Nhưng mà quan trọng bây giờ câu hỏi tiếp theo là thế thì cái hình tròn xoay đấy nó có cái bề mặt, thì diện tích bề mặt đấy là bao nhiêu? Hay người ta gọi là mặt tròn xoay. Right. So for example, you have this one, the cone, the right triangle, and you rotated it. Right? You have a cone. Các em có thể tính được thể tích của cái hình nón này. Yes. But how about the area of, ở bên ngoài, bên bề mặt của cái hình của nón, không tính bên trong, sao diện tích thôi. That the area. How to compute? This we want to talk about now. The key point in this computation is using arc length. Using arc length, using L of function or Sx as the arc length function. That's why we study surface area after studying of the arc length. So you see, cái diện tích này là có thể tích của nó, ta biết rồi. Okay, so that the ax you have v is integrand from a to b ax dx. This is the volume. But how about the surface area of that? Thể tích của cái bình hoa này thì các em đổ nước là các em biết là thể tích là bao nhiêu, là các em cần phải tính. Nhưng bây giờ nếu các em muốn sơn cái bình hoa này thành một cái màu khác hoặc cái hình khác thì các em phải biết được cái diện tích bề mặt, diện tích xung quanh của hình bình hoa này là bao nhiêu. Và đấy là bài toán surface area. Và bài toán surface area này thì nhiều sinh viên bị mắc trong những cái năm trước, là phải để ý kỹ xem người ta có yêu cầu tính diện tích hai cái base, hai cái đáy này hay là không. It depends, right? Depend on what you study. It depends on formula you use, give you what does it give. Okay? So read carefully the question. So the same idea by surface area, you can use the idea of finding area, volume, etc. The same strategy. Divide into equal part of interval. Each part you approximated it, and then you take the sum of all part, and then you find the limit. Again, do by yourself in the appendix I can give. If you want to know, here the idea in italic. See, all in italic. You have the circumference multiplied by the height, right? That each small part we call frustum. And you don't have to remember that only this circumference here, that one, see, multiplied by the length of that one. Then you get the area of this part. Summing up all the thing, letting n tend to infinity, what do you get? You get this sum, and then letting n to infinity, you have the formula 2 pi fx multiplied by the arc length. Very clear what you have to do, and very easy to remember the formula of that. Okay, so again, this learn by heart. Or remember by heart. This one. Okay, what you have? Look at that. Suppose that fx is non-negative and it has derivative which is continuous. It has a derivative which is continuous on the interval AB. We need this because we want to have this integrand exist. So this continuous, this also continuous, then integrand can be computed. In this case, if we rotate the curve about x-axis, that one, about x-axis, then the surface area is computed by this formula. Okay? Integrand from A to B, 2 pi fx multiplied by square root of 1 plus f prime square dx. This is the surface area, as we explain here in italic. You can read by yourself. So sometimes they also write like this because this is actually f prime of x, dy over dx, right? You can remember this one, 2 pi r. R is fx, means that the circumference, right? At each point, you have the radius. The radius is fx, right? And very easy, the radius here, because y is fx here, then this part is fx. So you have that this circumference, right? And this one is arc length. We already talked about from the beginning of today's lecture. Then it works. Remember only. So, example, find the surface area generated by rotating of parabola y equal to x squared from 1, 1 to 2, 4 about y-axis, not x-axis. Yeah, that y equal to x squared and rotating like that, then you get really cái này chả phải bình hoa nữa rồi mà là cái bình để trồng hoa, right? Bình để trồng hoa chứ không phải là flower vase nữa rồi. How about the area? You have to apply formula, but the role of x and y you have to change. Not this formula anymore. This formula for rotating about x-axis. Here you have about y-axis. See, so the role are changed, and you should pay attention. Okay, from y equal to x squared, you have x is square root of y. You take this one, right? That, and x also positive. You take here x square root of y, which means x is a function of y. Then you have x prime is gy prime with respect to y. And in this case, you have from A to B for x, you should change from C to D for y, where CD is range of y, and that x prime is g prime of y. See, they are different in role and do not confuse in this case, right? So from 1 to 4 you have, yes, yeah, y from 1 to 4, but x from 1 to 2, they are different. Pay attention, that's why you lose mark, right? So, and after having this, the thing only computation, right? No more. That computation to get again not beautiful numbers and answer, but it happened because square root of that 1 plus the x prime square, and then computing the integral usually not beautiful answer number, but we have to accept such a case. Okay, so and you see you have to perform the formula and then you compute. That the end of chapter 5. And the other part, you see, I already gave the appendix, explain what we did for each case using the same idea for finding the area of the region, right? Bounded by some curve, under the sum curve, by 4 steps. Division, divide the interval into n equal interval. For each sub-interval, you approximate it, what you want, and then you summing up the third part, and the fourth step is to find the limit. That's all. You get all the thing. And the same for cylindrical shell, you see, it looked quite beautiful, the same method, right? Oh, where is that? Yeah, the same method. See? What? Yeah. So, and you have, yeah, the same method here for step, and the answer, when you take the limit, you get this answer. That's all for the appendix. Done. We finish chapter 5. By the end of this week, I will be uploading the last 2 chapters, chapter 6 and chapter 7. Not easy to work on, but computation is less complicated. You see, when we have a time of midterm, I already talked about this at the beginning of the second hour. Who misses, then wait announcement or ask your classmate. I already told you. And I already explained. I won't repeat again. So you should follow my lecture. You should follow what I talk at all the time. I talk about that. And by the rule, I will be uploading, will be announcing 1 week before the midterm start. This is the rule of university. Okay, so talk to your classmate, because we have 250 students. Not everyone can follow my lecture, then ask your classmate. Understand? Any question? Yeah. Trông bạn Huỳnh Ngọc Linh kìa, bạn nói rất rõ ràng là hiểu rồi, không có câu hỏi gì. Còn những người khác nghe đấy mà hỏi nhau chứ không phải là cái gì thầy trả lời. Miss thì không có trả lời. Còn nếu muốn trả lời thì nghe cho nó rõ trong cái thời gian lecture ấy. Đừng có mà chạy đi ra ngoài, đừng có mà đến muộn. Ok? Đúng Huỳnh Ngọc Linh. Đúng rồi, gật đầu cười thế là đúng rồi. Yes. So, see you next week. for chapter 6 and chapter 7. We are approaching to the end. Already this, how many? We have 5 lectures more, right? 5 weeks more. And we can have. So again, I can tell you that because linear algebra is scheduled for midterm next week, we will have somewhere in January. Okay? Done. Bye-bye.
Goodbye, Professor.
Bye.
See you, Professor.
See you later, Professor.
Professor.
Bye, Professor.
You, goodbye.
Bye-bye. Bye-bye.
Bye bye bye.